In this video, let us understand the definitions of AI, ML, TL, and generative AI with practical examples. Artificial intelligence is a broad field that focuses on building systems capable of performing tasks that would normally require human intelligence. These tasks include understanding speech, making decisions, and adapting to new information. In our everyday lives, AI appears in many familiar forms. For example, virtual assistants like Siri, Alexa, and Google Assistant can understand what we say, answer our questions, and control our smart devices. In the financial sector, fraud detection systems uses AI to identify suspicious activities and prevent fraudulent transactions, protecting both banks and customers. And in the transportation, traffic navigation apps such as Google Maps use AI to analyze real-time traffic data and dynamically suggest the fastest routes to your destination. Machine learning is a branch of artificial intelligence that enables systems to learn patterns from data and make predictions or decisions without the need for explicitly coding every possible rule. One everyday example is email spam filters. These systems learn from large set of labeled messages, identifying which ones are spam and which are legitimate, so they can automatically filter your inbox. Another example is product recommendation systems used by platforms like Amazon and Netflix, which analyze your browsing and purchase history to suggest relevant products or shows. In finance, credit scoring uses machine learning models to evaluate loan eligibility by examining your financial history and identifying risk pattern. Deep learning is a specialized subset of machine learning that uses multi-layered neural networks, often called deep neural networks, to process and learn from massive amounts of data. These networks automatically discover complex patterns, making them ideal for highly sophisticated tasks. For example, facial recognition on smartphones uses deep learning to analyze and match unique facial features, allowing secure device unlocking. In the automotive world, self-driving cars rely on deep learning for perception tasks, identifying pedestrians, reading traffic signs, and detecting lane boundaries to navigate safely. In healthcare, medical image diagnosis uses deep learning to detect tumors or abnormalities in MRI and CT scan, often achieving accuracy levels comparable to experienced radiologists. Generative AI is a branch of deep learning focused on creating new content. These models learn patterns from massive datasets, then generate entirely new data, including text, images, audio, and even video that resembles what they have learned. For example, ChatGPT can produce human-like text responses, answering questions, writing articles, or drafting scripts. DALL-E and Midjourney can create realistic images from simple text prompts, turning ideas into visuals. In the music world, AI music generation can compose original songs in various styles. And in programming, tools like GitHub Copilot can assist developers by creating code snippets, suggesting completions, and even writing entire function. Artificial intelligence is no longer a futuristic concept reserved for research labs or tech giants. It has become a transformative force that touches nearly every profession, from healthcare and finance to manufacturing, education, and creative industries. For working professionals, AI is not just a tool, it is an enabler of smarter decisions, higher efficiency, and innovation at scale. Understanding AI's potential is essential to remain competitive in today's rapidly evolving job market. Artificial intelligence delivers value to professionals in three powerful ways. First, automating repetitive tasks. Routine time-consuming activities can now be delegated to AI-powered systems. For example, HR teams can use AI to screen resumes, accountants can process invoices automatically, and customer service teams can provide 24/7 support through AI chatbots. Second, enhancing decision making. AI provides data-driven insights that reduce guesswork and improve accuracy. Doctors can rely on AI-assisted diagnostic tools, financial analysts can predict market trends more precisely, and engineers can speed up product design using AI simulations. And third, unlocking innovation. AI enables the creation of new possibilities, products, and services. Designers can generate concept art with AI, marketers can personalize campaigns with AI-driven analytics, and researchers can accelerate discoveries with AI-assisted analysis. In short, AI is not just about efficiency. It is about smarter decisions, faster growth, and unlocking creativity at scale. One of the most powerful aspects of artificial intelligence is its domain agnostic nature. In simple terms, AI strength lies in its ability to learn patterns from data, no matter which industry it comes from. For example, in healthcare, AI can analyze medical scans. In retail, it can study customer purchase histories. In manufacturing, it can detect patterns in machine vibration logs. And in education, it can track student performance metrics. The same core principles of AI, learning from data, finding patterns, and making predictions, apply everywhere. That's why AI is not limited to one profession or one sector. It is truly universal. Ignoring artificial intelligence is no longer an option for professionals. Those who fail to adapt risk falling behind peers who are already leveraging AI tools. They may lose efficiency, lose competitiveness, and even miss out on opportunity for innovation. In contrast, professionals who embrace AI gain a strong advantage. They build career resilience in a tech-driven world. They learn how to collaborate effectively with AI systems, and they open doors to lead transformation projects in their fields. Simply put, AI will not replace professionals, but professionals who use AI will replace those who don't. Let us look at some real world case studies of AI across different domains. In healthcare, AI-assisted radiology helps doctors deliver faster and more accurate diagnosis. In finance, AI-powered fraud detection systems reduce financial losses by identifying suspicious activity in real time. In manufacturing, predictive maintenance powered by AI lowers downtime cost by detecting machine issues before they become failures. In marketing, AI enables smarter customer segmentation, which leads to higher campaign return on investment. In education, personalized learning platforms adapt to each student's progress, creating better engagement and outcomes. And in law, AI speed up document analysis, allowing legal professionals to prepare cases more efficiently. These examples show that AI is not limited to one industry. It is transforming every profession it touches. Here are the key takeaways for professionals when it comes to artificial intelligence. First, AI is a skill amplifier. It doesn't replace you, it enhances your abilities. Second, AI literacy is now a core competency, just like digital literacy was essential 20 years ago. AI literacy is a must-have skill today. And third, AI does not create users, it creates leaders. Those who truly understand AI will be the ones shaping how it is applied in their field. What is the bottom line? AI is not just the future, it is your competitive advantage today. Welcome to this presentation on evolution of artificial intelligence. AI has come a long way from simple rule-based systems to powerful tools that can create content, mimic human creativity, and handle complex tasks. This progress didn't happen overnight. It was built step by step through revolutions in how machines perceive, learn, and generate. In this journey, we'll explore four major areas of AI: symbolic AI, statistical AI, deep learning, and the exciting new frontier of generative AI. Each stage pushed the boundaries of what machines can do, and by understanding this evolution, we will be better prepared for the present and the future. Whether you are a developer, a researcher, or a decision maker, this knowledge gives you the context you need to make smarter choices with AI. So, let us begin with a quick overview of these four transformative stages. Artificial intelligence didn't appear overnight. It's the result of decades of progress in both ideas and technology. In this presentation, we will look at AI's journey through four big eras, each one reshaping what machines can do. First came symbolic AI, where rules and logic were written directly into machines. Then statistical AI, using data and probability to make smarter predictions. Next, deep learning, where machines began uncovering complex patterns from massive amounts of raw data. And today, we are in the era of generative AI, where machines are not only analytical but creative. Understanding this journey is not just theory. It helps professionals choose the right tools and models for the real challenges they face in their fields. So let us dive in, starting with the foundation, symbolic AI. Let us start our journey in the 1950s with the symbolic AI, the rule-based era. Back then, The belief was that intelligence could be built by manually encoding knowledge into machines. Programmers wrote logic step by step. If this happens, then do that. This approach was deeply inspired by formal logic and mathematics. Symbolic AI led to some of the earliest breakthroughs. For example, Mycin, an expert system for treating infections, could even outperform junior doctors in certain cases. Early chess programs also used handcrafted rules and decision trees to make their moves. These systems were clear and transparent, and they work well in very specific tasks. But they were also brittle. A small change in input could break the whole system, and updating them meant rewriting massive set of rules. Because of these limits, researchers began searching for more flexible and data-driven approaches. That shift brought us into the next era of AI, that is statistical AI. The 1980s brought a major shift in the AI, from symbolic reasoning to statistical learning. Instead of programming every rule by hand, engineers began building models that could learn patterns from data using probability and statistics. This era gave us practical systems like spam filters powered by nav bias and early speech recognition models using hidden macro models. These approaches made AI more adaptable to real-world situations, even when the data was noisy, inconsistent, or incomplete. But challenges remained. Models required a lot of manual effort to engineer the right features, and the classic phrase applied: garbage in, garbage out. The quality of the results was tightly bound to the quality of the data. Still, this era built the foundation for next revolution in AI, that is deep learning. The 2010s marked the rise of deep learning, a turning point in AI powered by stronger computers and smarter neural network designs. Unlike earlier methods, deep learning models could automatically extract useful features straight from raw data. No heavy manual pre-processing is needed. So this era brought huge breakthroughs. Neural networks dominating image recognition, recurrent and transformer models driving advances in language translation, and deep architectures revolutionizing speech recognition. These systems proved that with enough data and compute, AI could reach and sometimes even suppress human level performance in specific tasks. But these were trade offs. Deep learning demanded massive datasets, enormous computing power, and the models often work like black boxes, difficult to explain and harder to fully trust. Still, this era set the stage for the next big leap in AI, that is generative intelligence. We have now reached the current frontier of AI, the era of generative models. Unlike earlier systems that only analyzed or classified data, generative AI can create new content. From human-like conversions to stunning digital art, these models extend and even mimic human creativity. This revolution is powered by transformer architectures and large-scale training. Tools like ChatGPT and GitHub Copilot are everywhere, helping people write, design, and code. They are not just boosting personal productivity, they are transforming entire industries. But with this power come new challenges. Generative AI can produce misleading content, amplify biases, and raise difficult ethical and legal questions. That's why adoption must go hand in hand with responsibility, transparency, and thoughtful design. Understanding the evolution of AI is not just theory, it is highly relevant for today's professionals. Each era of AI brought new strengths and new limits. By learning from them, we can choose the right tools and avoid repeating past mistakes. For example, Symbolic AI taught us transparency, Statistical AI introduced adaptability, Deep Learning gave us perceptual intelligence, and Generative AI unlocked creative synthesis. These approaches are not interchangeable. Each has its strength and weakness, depending on the problem you are solving. As generative tools become more common, it is important to use them statistically, not just reactively. Whether you work in business, healthcare, law, or creative arts, your understanding of AI journey will shape how well you can lead, innovate, and adapt. To wrap up this journey, we have seen how AI has grown from handcrafted rules to probabilistic models to powerful neural networks that can both perceive and now create. Each era expanded what machines could do, and each brought new opportunities along with new challenges. Today's AI is at a convergence point. It's not only generating text and images, but also being woven into fields like bioengineering, healthcare, and education. But with this power comes responsibility. The more capable our systems become, the more important it is to design them with ethics, accountability, and purpose. As professionals, we are not just users of AI, we are stewards of where it goes next. By understanding the past, we are better prepared to shape a future that is innovative, inclusive, and intelligent by design. AI is not just the future, it is already here, transforming industries today. This presentation opens with a look at how different sectors are using AI, driven by real practical use cases, not theory. In finance, where every millisecond counts, AI powers fraud detection and automate trades, delivering speed, precision, and risk control. In healthcare, AI enables rapid diagnosis and support personalized treatment planning. In retail, AI thrives on predictive personalization, helping business understand and serve customers better. And in manufacturing, AI drives intelligent automation, streamlining operations, and boosting efficiency. Across all these industries, the lesson is clear. While the data and code may differ, the power of AI lies in adapting common techniques to deliver measurable value. Let us explore each of these sectors more deeply. Finance is the one of the most advanced sectors when it comes to AI integration. The sheer volume and velocity of transactions make it a prime candidate for machine learning solutions that can process data in real time. Fraud detections has evolved from rigid rule-based systems to dynamic ML models that adapt to changing behaviors. Algorithmic trading now uses deep learning to spot and exploit patterns faster than human traders ever could. Meanwhile, AI enhances grade scoring by considering behavioral data, opening doors to wider financial inclusion. Customer service also benefits with AI-powered bots that understand intent and manage even complex workflows. So the result is banks are saving cost, reducing fraud, and delivering a smoother customer experience. AI's impact in healthcare is deeply human. By improving the speed and accuracy of diagnosis, AI empowers doctors to begin treatment sooner, especially in critical conditions like cancer. One standout case is medical imaging. Deep learning can scan images in minutes, catching signs that even experts might miss. Predictive analytics also play a big role, helping hospitals forecast high-risk cases and allocate resources more efficiently. Beyond diagnostics, AI is speeding up drug discovery by identifying promising candidates faster. And for patients, digital health assistants provide guidance and support right at their fingertips. The result is personalized, proactive care delivered at scale. In today's competitive retail world, the edge comes from personalization and precision, and AI makes both possible. Recommendation engines, driven by vast amount of customer data, deliver the right product at the right time and that dramatically boost sales. Forecasting tools help avoid both overstock and missed sales by optimizing inventory based on real demand. Dynamic pricing adds another layer, adjusting offers in real time to stay competitive. Even in physical stores, computer vision is transforming shopping from instant checkout to smart self alerts. The result is a faster, smarter, and more customer friendly retail experience. In manufacturing, AI delivers efficiency at scale. Predictive maintenance cuts down on unplanned downtime, directly improving output and reducing cost. By analyzing sensor data in real time, systems can anticipate failures and trigger repairs before they happen. On the quality side, computer vision spot product flaws with incredible speed and accuracy, making sure only the best product reach customers. In supply chain logistics, AI predicts optimization routes, keeping production lines running smoothly. And then there is robotics. Intelligent machines powered by AI now adapt to complex and changing tasks. The result is leaner operations, safer workplaces, and a strong bottom line. This matrix shows the cross-sector impact of AI. The tools may be the same: machine learning, computer vision, natural language processing, but their use looks very different depending on each industry needs. In finance, speed and accuracy matter most. In healthcare, it is all about reliability and life-saving precision. In retail, the focus is understanding customers in real time. And in manufacturing, the priority is operational consistency and safety. Despite these differences, one pattern is clear: AI delivers the most value when it is built into specific high impact processes. That is where the real return on AI investment comes to life.